In today's video, we will discuss some very important points on how to test this PCB and identify the specific points where you need to check the voltages. This will help you understand where the fault lies in the PCB. Although this method cannot be applied to every PCB, it will give you an idea of how to test voltages effectively. However, before checking the voltages, it is essential to electrically discharge the PCB. This is because if you don't discharge it, you could get a shock, especially if the PCB was recently unplugged. This happens because the capacitors on the PCB can hold a heavy charge. Now, I'll show you how to discharge the PCB properly. To discharge any PCB, you need to have a soldering iron. Ideally, the soldering iron should have an indicator light so you can see the charge being drained. I'll now demonstrate how to discharge the PCB. The soldering iron will absorb all the charge. However, the company has also provided two designated points for discharging, which you can use. Alternatively, you can directly discharge the capacitor by placing probes on its positive and negative terminals. Watch as the light turns on and then off, indicating the charge has been drained. This is how you can safely discharge the PCB. Now we will test the PCB by supplying it with electricity. However, before this, I showed you how to discharge capacitors, and that was specifically for when you're checking a component. But since we are now checking voltages, we will test the PCB by powering it on and measuring the voltages at different points. At this moment, we have supplied power to the PCB and turned it on. You can see that its LED has lit up and the switching is functioning correctly. This indicates that the PCB is in perfect working condition. However, if you receive a faulty PCB, you should know what voltages should be present at which points to diagnose the issue properly. Set the multimeter to AC volts. First, you should check for 230 to 240 volts at the input. Here we are reading 235, 238 volts, which means the input is fine. Next, move to the filtering stage to verify if the system is functioning correctly up to that point. Place the probes on the filtering points, and here we are getting 239 volts, indicating this stage is also fine. After that, check the PTC and the resistor with zero resistance. To test this, place one probe on the resistor and the other probe back on the capacitor. You should still receive an AC voltage reading. Here, we are getting 239 volts, confirming that the resistor and PTC sensor are also in working condition. After this, the system moves to the rectification stage. At this point, the inner terminals should show 230 volts. Here, we are reading 239 volts, which indicates that everything is fine up to this stage. Next, the points beyond this need to be checked in DC mode, so set your multimeter to DC volts. After rectification, you should get 320 volts. Here, we are reading 329 volts, which is correct. Following that, check the electrolytic capacitors. They are also showing 329 volts, confirming there is no issue with them. The next point to check is the SMPS, switched mode power supply. This entire section is the SMPS. Once low voltages are generated here, only then will your unit start functioning. Now, to check the SMPS, you first need to verify its rectification. Look at the small black rectifier here. Since this is a compact system, a small 2 ampere rectifier is used. When measuring DC volts at this rectifier, you can see it shows 327 volts, which indicates it's functioning correctly. Next, check the AC voltage at the same point. Here, it shows 238 volts, which again confirms that it's in good working condition. Along with this, check the filtering capacitor. It also shows 326 volts, confirming that it is operating properly. Now look at this SMPS. This is its high side and this is its low side. Here, 3 capacitors are installed where different voltages are present. Let's check the voltages on these capacitors step by step. On the first capacitor, we are reading 5 volts. On the second capacitor, we are reading 15 volts. Finally, on the third capacitor, we are reading 12 volts. All these readings are correct, and the voltages on all 3 capacitors are as expected. This confirms that this section is functioning properly. The next point to check is the IPM. You need to verify the voltages present on the IPM. When examining the IPM, there are 2 sides, the low side and the high side. On the low side, you should get 15 volts, and on the high side, you should get 327 volts. Checking between the negative and positive terminals, the reading shows 330 volts, which is correct. Next, check the UVW points, where 15 volts should be present. Here, we are reading 14.57 volts, which is within an acceptable range and indicates proper functioning. Additionally, there's one more critical point to check. This is a diode responsible for supplying 15 volts throughout the circuit. If 15 volts are missing, this diode might be faulty. Make sure to check this diode, as it plays a vital role in distributing the 15 volts required for proper operation. The next point to check is if your microcontroller is not turning on or functioning functioning correctly. This could be due to the 3.3 volts being missing. Now, look at this IC, which is a low voltage regulator responsible for supplying 3.3 volts. To verify, check the voltage at capacitor C73, where you should read 3.3 volts. Here, we are getting 3.291 volts, which is almost exactly 3.3 volts, indicating that everything is working properly. However, if you do not get 3.3 volts at this point, it means either the IC or the capacitor is faulty. Here, there is another important thing to check: the communication. In a previous video, I explained how a communication issue can cause problems. Now, at the starting point, there is a capacitor involved in the communication system. Check this capacitor, and you should get a reading of around 58.5 volts. Here, we are getting 58.5 volts, which confirms that the communication system is functioning properly. Now, the PCB has been discharged again. Look at the optocouplers installed here. If your communication system is not working and you're encountering an E6 error, you need to check the voltage at points 1 and 2 of the U7 optocoupler. At these points, you should measure approximately 0.32 volts. If this voltage is present, it indicates that this part is functioning properly. Additionally, you need to check if 3.3 volts are also present. If you're getting 3.3 volts, it confirms that the optocoupler is in good working condition. Now let me show you the next point to check. Look at the C50 capacitor. At its negative and positive terminals, you should also measure 3.3 volts. If you're getting this voltage, it means this section is functioning properly. Additionally, check the resistor R67. Place one probe on this resistor and the other on the capacitor. You should also get 3.3 volts here. If these voltages are present, it confirms that your communication system is working correctly. This is how you can systematically check all the voltages to ensure everything is functioning as it should. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.